apps have been developed which shift from a blue enriched screen to a more red enriched screen, taking it away from the blue light. There is absolutely no data that shows that this has any effect at all.
So, Professor Russell Foster, thank you so much for joining me today. I have just read your wonderful book, Lifetime, and we are going to talk about a number of things, but primarily the circadian rhythm. And I am absolutely delighted to get this opportunity because it's not something that we often think about. As a starting point, Professor Foster, would you mind just introducing yourself and letting the listeners know where you work and what your kind of key interests are?
Well, first of all, I'm delighted to be able to join you today. And please call me Russell, not Professor Foster. Yes, formally, I am Russell Foster, Professor of Circadian Neuroscience, and I'm Director of the Sleep and Circadian Neuroscience Institute. And I also head the Nuffield Laboratory of Ophthalmology, which is the sort of research arm of the Oxford Eye Hospital. So that's my day job.
Brilliant. Well, look, there is so much to cover in this that we're just going to jump straight in, if that's okay with you. Let's start with some science, like we always like to do with these interviews. What is a body clock and how does it work?
If we just step back and think about what our bodies and our biology is supposed to do, it's deliver the right stuff at the right concentration to the right tissues and organs at the right time of day. And we have to have this sort of this change because of course we live on a planet that revolves once every 24 hours and the demands of activity, rest, sleep are completely different. We're in very different sort of metabolic or cognitive states across the day. And what the circadian system does, the body clock does, is provide a time structure for our entire biology. It allows us to do the right thing at the right time. And in fact, without that time structure, our biology begins to fall apart. And the analogy I've made is that it's a bit like an orchestra with all the musicians playing at a slightly different time. So instead of a symphony, you have this cacophony. And what the circadian system does is a bit like the conductor, which is give a time signature to make sure that everything happens in the right order and the right time.
Now, we often think when we think body clock, we think of sleep. And obviously, that plays an important role, and we'll come to that shortly. But do you mind just giving us a little bit of an idea of some of the other body functions that you mentioned? What sort of things are influenced by the body clock?
Well, you name it. I mean, so in anticipation of going to sleep, our core body temperature drops, our metabolic rate changes somewhat. We begin to shift from a metabolism which is burning up the calories we've taken in the day to a metabolism which is liberating stored calories so that we can survive over the night when we're not consuming more calories. If we look at our anticipation of waking up in the morning, our core body temperature rises, our heart rate rises, our liberation of glucose into the circulation goes up, all anticipating the increased demands of activity. And you also find that our cognitive abilities will change markedly over the day. So for adults, we're peaking in our cognitive abilities around about noon. It depends upon the individual, whether you're a morning type or an evening type, but our cognitive abilities really show a profound change, such that in the early hours of the morning, our ability to process information is worse than if we consume sufficient alcohol to make us legally drunk. That gives you a sense of the dynamic changes. So just about anything. Another area I think which is fascinating is immune function. So our immune system tends to be turned down a bit during the latter half of the day and at night, whereas it's turned up during the day. And this has been translated in some very interesting areas, such as vaccination. So, vaccination for one of the flu viruses in 70-year-olds showed that the antibody response was threefold higher if the vaccination was given in the morning rather than the late afternoon. So, just about everything is being modulated by this internal day, this internal representation of time.
You kind of alluded to it there that people don't all have the same type of body
Yeah.
clock. So tell us a little bit about that. What and how many different types of body clock are there?
Yeah. Well, this is a phenomenon called one's chronotype. Um, and I like the old classification, which is, larks, which is about 10% of the population, owls, maybe about 25% of the population, and the rest of us are doves right in the middle. You'll find lots of other terms like dolphins and lions, and I think these actually are not very helpful, but in fact, somewhat misleading. But what it essentially means is your preference for your sleep wake cycle. And so for an owl, you would be going to bed between midnight and 4 o'clock in the morning. It can be that late. But if you're a lark, you could be going to bed at 7 o'clock to 9 o'clock in the evening. Now, the really fascinating thing is, well, what makes us a lark or an owl? And there are three, maybe four important factors. One is genetics. So we now know that certain changes or polymorphisms in the genes that underpin the biological clock can nudge you earlier or later in time. So genetics is one factor. And as somebody once said, by their contribution to our genes, our parents are still telling us what time to go to bed and get up. I really like that. The second is how old you are. So from about the age of 10, as we age, we tend to want to go to bed later and later. And for males, they peak in their lateness around about 21, 21 and a half. For females, about 19, 19 and a half. So women tend to peak earlier than men, and they're never quite as late as men. But from the late teens to the early 20s, there's a very, very slow movement to want to go to bed earlier and earlier. So the key point is by the time you're in your sort of late 50s, 60s, you're getting up and going to bed on average about 2 hours earlier than you did when you were in your late teens, early 20s. And I think many people, comment on this that, oh, I find myself feeling sleepier much earlier than I did when I was much younger. So you've got genetics and you've got age. And what's underpinning that change with age is probably the sex steroids. So from about 10 to the late teens, early 20s, there's a huge change in those hormones, testosterone in men, progesterone, estrogen in women, and then a slow change, a decline in those hormones as we age. And that seems to be, it's not exclusively, but that seems to be the dominant issue that's changing our chronotype as we age. And we do know from animal studies that the sex steroids, particularly estrogen and progesterone in females, will have a big influence of sleep-wake timing. And the third factor is when we see light. So morning light advances the body clock. We get up earlier and go to bed earlier, whereas dusk light delays the clock. We go to bed later and get up later. And this is something we can have some control over. A study that we did a few years ago on university students all over the world showed that the later the chronotype, the more owl-like an individual was. The less morning light they got, which would advance the clock, make them get up earlier, but they were getting that late afternoon dusk light, which was shifting the clock later. So if you happen to be a late type and you want to get up earlier, then it's brutal, but it works, that you set the alarm clock, you get a good exposure to light, either by going outside, but of course you may need to use a light box as well, and then that will advance the clock. And you need to do this every day to keep it on track. But that's a key point. It's when we see light.
Is it exclusive to humans, a body clock? And I guess the second thought that I had was, is there an evolutionary advantage to that sway as we age? Has that ever been proposed? Is there
Yeah,
is there a benefit?
it's the sort of thing that when we go to meetings, this is what we talk about all the time. No, this really interesting question. And are there clocks outside of humans? You bet. Almost all life on the planet, even some bacteria, have an internal representation of a day, which they fine-tune their biology to these very demands of the light-dark cycle. So, for example, if you're exposed to light during the day, then the UV in that light could potentially damage your DNA. And so what you find in simple organisms, bacteria, they tend to do their DNA repair and their DNA replication in the dark rather than risking exposure to ultraviolet light, which might damage some of the DNA. But the fascinating thing where we differ, and I think the fascinating thing about humans, is that we show this terrific chronotype range. If you look at a mouse or basically anything else, it's all about the same timing. You don't have the larks and the owls that are so characteristic of our species. And there's been lots of discussion about this. And one argument, and we can never know for sure, is that that diversity of alertness or activity across the 24-hour day may have been useful in tribal communities where vigilance across the day and the night might have been really important. Now, we don't know, but it kind of makes sense in that you would always have somebody within the group who's got an eye out about what's going on out there, and that could be very useful. I think it's a fascinating idea. How the heck we test that, I don't know.
Okay, so just keeping on the science a wee bit, do you mind just giving us a little bit of insight into what's regulating it? What's happening internally and what things impact our circadian rhythm?
Yeah. I was lucky enough to be in the United States when some of the formative research in this area was unfolding. And one of the things that I was part of the discovery of with Martin Ralph and Mike Menneker is the nature of the master clock within the brain. There's a structure deep within the brain, within the hypothalamus, and it sits above where the optic nerves go into the brain and fuse. And it's a structure called the suprachiasmatic nuclei, mercifully abbreviated to SCN. And that seems to be the master clock within the body. Then it was discovered that individual clock cells within this structure, and there are around about 50,000 in each SCN, in humans, that you could take one of those cells out and it would show a 24-hour oscillation in isolation, which told you that the clock isn't the product of cell-cell interaction, which is what we originally thought. We thought it was an emergent property of a circuit, but rather a subcellular molecular mechanism. And of course, the Nobel Prize in 2017 was given to Young, Rosbash, and Hall for their characterization of the molecular clock, not in humans, not in mice, but in flies, in fruit flies. And what turned out to be the case is that you've got a bunch of clock genes which are turned on. They make proteins. Those proteins form a complex. They go into the nucleus and they turn their genes off. Those proteins are then degraded, and so the genes can start to make message and then proteins again. So what you have is a cycle of protein generation and then degradation, and that's at the heart of the clock. So you've got about 100,000 in total, 50,000 in each SCN, working together to generate a coordinated circadian output. And what we originally thought is that, well, this clock is simply imposing, forcing 24-hour rhythms on the gut, the liver, you name it. And then it was discovered that every cell in the body has the capacity to generate a circadian rhythm. So what's happening is that the master clock in the brain is coordinating the rhythmic circadian activity of billions and billions of individual cellular oscillators organized throughout the various tissues and organs of the body. So we use the shorthand of a body clock, but actually what we've got is this extraordinary sort of time structure, this circadian system that is fine-tuning and regulating everything we do. Okay, it's great. You've got that internal timer. But it's of absolutely no use. It's no adaptive value unless the internal day is locked on to the external world. And of course, our classic mismatch would be jet lag. When we fly across multiple time zones, our body time thinks you are still back in Glasgow, but in fact, you've moved forward or back in time to either the United States or Australia. And so it takes us a while for our internal circadian systems to adapt to the new time zone. And how do we do that? Well, it's primarily, but not exclusively, exposure to the light dark cycle. That's what's so important in setting the internal clock to the external world. Now, we can help it by eating at the local times and maybe doing exercise at local times. But it's primarily light that is the entrainment cue for making sure that everything is beautifully aligned with the external world.
So, would you mind giving us a little bit of insight into how that works? Because I know that your research was very much focused on this.
Yes.
How is it working? What is the light doing? How is that impacting our circadian rhythms?
Yeah, this is yes, you've how long have we got? I'm gonna summarize about 40 years of interest and work. So I have been fascinated about how light is detected and how it regulates rhythmic systems. In fact, my PhD work was actually on birds and how they detect day length, which then, the increasing spring day lengths trigger reproduction. So there's a wonderful example of how light is being used to regulate a rhythmic process. And I was fascinated about the photoreceptors, the light sensors that birds use for that. Um, if we move to the mammals and the work we did on mice, it always struck me as being curious that the only organ that is used for the detection of light in mammals to regulate the clock is in the eye. And we know that because if you cover the eyes of a mouse or a human, or if you have no eyes, then the clock will continue to tick, but it'll drift through time. So most of us, for example, have a body clock which is slightly longer than 24 hours. And so, under constant conditions with no eyes, for example, you would get up a little bit later and later and later and later each day. And we've worked extensively with people who have lost their eyes. And what it emphasizes is the fact is that the eye has a dual function. It's the organ of space, it gives us our sense of vision, but it's also the organ of time because it's that light that is picked up by the eye that regulates the clock. And when you talk to individuals who've sustained massive trauma to the eyes, they sort of say, "Look, I can cope with not being able to see, um, but what I can't cope with is my body constantly trying to fool me." And I was told one really rather poignant story of this chap had lost his eyes, but he was determined to work out ways in which he could overcome this loss. And so he was determined not to have the messy front garden. So he'd worked out a way, he was completely blind, to go to the shed, get out the lawnmower, to cut the lawn, and there were little things he could push up, and so he knew he'd come to the edge of the lawn, turn it round. And so he'd worked all this out. Just amazing. And on one occasion, his wife came down and tapped him on the shoulder and said, "It's 3 a.m. in the morning. You're waking up the neighbors." And we kind of smile at that. But, when you're trying to gain control after this traumatic loss, you can do it in lots of ways if you're blind, but you can't if you've got no regulation of the clock. But the point I'm trying to make is that the eye is doing two things. It's regulating our vision, of course, but it's also regulating our time. And the question we asked really quite some years ago now is, how does it do that? The visual cells in the eye, the rods and the cones, give us our sense of space. And we wondered, well, presumably it's those photoreceptors that are regulating the clock. But for various theoretical reasons, I wondered if that was the case. Because what vision has to do, and the rods and cones, is grab light in a fraction of a second and then make an image of the world. It's taking a snapshot of the light environment in a fraction of a second. But what the circadian system needs is an overall impression of the amount of light in the environment over relatively long periods of time. So, anyway, we started looking at mice with hereditary retinal disorders. These mice were being explored to try and understand the genetic basis of blindness in humans, relating key genes to visual processing. And we looked at mice who had these gene defects and were visually blind. And we looked at the effect of a light dark cycle on their ability to regulate their clock. And what blew us away was that these responses, the circadian system, could still be regulated by the light dark cycle in the absence of any visual responses in these animals. And it wasn't that they had some residual capacity. These mice could do this with the same sensitivity as those mice that had rods and cones. And anyway, we did 10 years of study on this, and there was huge opposition. I remember at one meeting, standing up and saying, well, these data are consistent, with the fact that the eye could well contain another unrecognized light detecting system. And at this point, somebody stood up in the audience, looked at me, and I thought they were going to ask an early question. They just said, bullshit, and walked out. I mean, it was ferocious, in fact. I remember one person said to me, "Are you seriously expecting us to believe this? We've been studying the eye for 150 years, and you're telling us we've missed an entire light sensor." Of course, I was relatively young in those days, full of confidence. I said, "Yes, based upon the data, that's it." And of course, from that point on, ultimately it led to the discovery of this third light sensing system within the eye. So the ganglion cells of the retina, they send their axons out of the eye, they form the optic nerve, and that goes into the brain. And what we discovered in mice and other researchers in monkeys and rats, and we also discovered this in humans, that a small number of those ganglion cells is directly light sensitive. They are photosensitive. So we've got photosensitive retinal ganglion cells, maybe 1%. And what they do is form this light sensitive net encompassing the arc of the eye, and they're used to detect environmental brightness, and it's that information that goes into the master clock in the brain, alters the gene expression of that molecular clockwork, aligning it to the outside light dark cycle. So that's what I've been thinking about for some considerable time, along with many colleagues. And I have to say, it's been an exciting time because the people that scream bullshit um, have now been involved very graciously, giving me some wonderful awards for the discovery of a completely new light sensing system within the eye.
Tell me, light obviously impacts sleep. We know this, and we hear a lot about blue light and morning light,
Yeah.
evening light. Would you mind just kind of, giving us a little bit of more insight into the impact of light on sleep?
Yeah. Well, those photosensitive retinal ganglion cells have a specialized photopigment, which is maximally sensitive in the blue part of the spectrum. And it's, for those of you who want to know the details, it's 480 nanometers. And what that translates to is the blue of a very beautiful blue sky. And this led to lots of ideas that blue light is going to be potentially useful, yes, but also potentially disruptive. So an argument arose that, okay, well, we know that dusk light delays the clock, means you get up later the next day. So blue light could be really bad for you in delaying the clock if you get blue light in the evening. So this was based upon theory. And on the basis of that theory, people said, oh, you shouldn't look at a computer screen, which is blue enriched in the evening. And so apps have been developed which shift from a blue enriched screen to a more red enriched screen, taking it away from the blue light. And there's also apps that you can use on your smartphone for this. There is absolutely no data that shows that this has any effect at all, which is really quite striking. And there's a very interesting study also about light in the evening from electronic devices. Some of your listeners may remember some headlines that if you look at a Kindle before you go to bed, then you're going to massively disrupt your sleep-wake cycle. Well, it's worth digging into the data. So, what individuals were asked to do was to look at a Kindle on its brightest light setting for 4 hours immediately before bedtime, before you're going to sleep, on 5 consecutive nights. And at the end of 5 nights in this group of individuals, sleep was delayed by 9 minutes, just statistically significantly. And in fact, I remember one of my colleagues at the time said, well, that may be statistically significant, but that's biologically meaningless. Now, that light did have an effect upon the hormone melatonin. It did shift the rhythm in melatonin, and it did suppress the melatonin. But it raises a really important point too, that melatonin is often called the sleep hormone. Well, it isn't. It's a mild modulator of sleep. And these studies showed that brilliantly. Sleep-wake timing was delayed by about 9 minutes, and it didn't correlate with the marked changes that were seen in melatonin. Okay, so that's where a lot of this started. However, a Scandinavian group then sort of repeated these experiments, but rather than keeping the subjects under dim light during the day, 90 lux during the day, prior to the 30 lux Kindle exposure in the evening, they gave them 500 to 600 lux for several hours during the middle of the day. And that completely abolished any effects on behavior and any effects of melatonin. So if you're getting even moderate levels of light during the day, you're not going to be bothered by dim light in the evening. It seems that if you're exposed to dim light during the day, it sensitizes the system and makes it a bit more sensitive to light in the evening. Most of us, of course, are getting light during the day, and the Kindle conclusion is largely as an artifact of the experimental methodology. And this is what we're finding all the time. The claims that are made ultimately are not being substantiated. So the bottom line here is that, yes, if the light is bright enough for long enough, you will delay the clock in the evening. But for most applications, looking at a computer screen, reading your Kindle, sitting in a sitting room, you're going to have almost no effect upon the clock at all. And if you've been out during the day and it's been exposed to moderate levels of light, it's going to desensitize the clock to evening light. So those issues have sort of emerged. But the whole business about blue light, it's got to be blue light. Well, that's based upon the fact that these photosensitive retinal ganglion cells are blue light sensitive. But what we now know is that the rods and the cones, those visual cells, can interact with those photosensitive retinal ganglion cells. So we have a short wavelength cone peaking at 420 nanometers, so in the sort of violet range. We have two green cones, which are sort of peaking at 530 and 560 nanometers, and the rods peaking at 500. So there's a potentially very broad spectral input into those photosensitive ganglion cells. How they interact is unclear, but we do know that they do, and it may well be that they're not simply additive. So, for example, that short wavelength cone could actually be inhibitory. So just saying it's blue light, is a gross oversimplification. There's other receptors, the visual cells, modulating the responses of those photosensitive ganglion cells. The tragedy is we don't have enough information. We know that you need bright light of a long duration, but we don't precisely know how much. We know that light during the day can modify your responses to light in the evening. We know that there's huge individual variation between people and their sensitivity to light. We know that age changes our responses to light. We've touched on the fact of whether you're inside or outside, your light history. So there's lots of things all interacting. And what we don't have at the moment is a sufficient, in my view, evidence base to make recommendations for our exposure to light. So you'll see statements like you shouldn't see more than 30 lux 2 hours before you go to bed. Well, I think that's really misleading and potentially dangerous in the sense that if you're an elderly individual moving around your environment, you want bright light to see. We also know that elderly people are less sensitive to light in terms of their circadian system. So these sort of bland statements, I think, are misleading. And we need a better evidence base to have specific recommendations, and we don't have it yet.
How has modern life impacted, I guess, our exposure to light and therefore our body
Yeah.
clocks?
So what's happened, if we go back to 1800, more than 95% of the population worked outside. They got a daily light dark exposure, which changed, of course, across the seasons. Now it's estimated that 2% of the population work in agriculture and fisheries. So let's say maybe 5, maximum 10% of the population are spending a lot of time outdoors, which means we've retreated inside. And so we've cut ourselves off from that vital element, which is the light dark cycle that regulates internal time. And we live in dim, dark places. And I would urge your listeners to download a lux meter, a light meter, onto their smartphone, because that's a great way of getting a sense of how much light there is outside versus inside. So shortly after dawn, environmental light is some 50 to 100 times brighter than the sorts of light we would experience inside. And as I said, it's that morning light that is very important for the regulation of the clock. So what type of light do we actually need? Well, the clock needs probably thousands of lux for a good half an hour to an hour. So the experiments that have been done have shown that 10,000 lux, which is the sort of light you'd see outside in the morning, um, for half an hour is a robust way to regulate the clock. Average sitting room light levels in the evening would be 90 to 100 lux or lower. So we're getting dim light inside. In an office, you might get 2 to 400 lux, but it's still much, much lower than the sorts of light you get outside. So we're now being exposed to a weak light dark cycle. And of course, since the 1950s, what we've been able to do with cheap, efficient light is invade the night. So we're invading the night, but that light is dim. And so what's happened is that we've, to some extent, detached ourselves from the light dark cycle, and we've invaded the night, and sleep has been the first victim. And we've thrown sleep away without appreciating its fundamental value and its fundamental importance. And those of us who remember the 80s will certainly remember people saying, "Oh, yeah, I've done another all nighter." And people sort of slap them on the back and say, "Oh, well done, fantastic, you've beaten sleep." Whereas now I think we're beginning to appreciate, no, 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 this is really bad. You don't want people coming into the workplace who have a weakness in their ability to process information, a failure to appreciate the social signals by other individuals, a lack in creativity, and a failure to multitask. So we're beginning to understand why sleep is so important and why you just can't throw it away as sort of an indulgence or treat it as an illness that needs a cure. So really from the 1950s onwards, because we can illuminate our spaces cheaply and safely, we've chosen to invade the night and sacrifice sleep. And so that's been the unremitting march of human society. But I am an optimist, of course, by nature, and I'm beginning to feel that there's a definite pullback against that attitude that absolutely was embedded in the 1980s.
So, why should we care about our body clock? You've clearly alluded to some of it, but I guess the extreme element of it, what happens if we don't live in sync with our body clock?
And this is what's emerged so excitingly over the last 20 years, and why I think people are taking sleep circadian rhythms much more seriously than they have done before. So much of our understanding of the importance of sleep circadian rhythms is because what happens if we disrupt them? And you can think about this disruption in three domains: its impact on our emotional responses, our our cognitive responses, our ability to process information, and long term, what's happening to our physiology and our health. If we think about emotional responses, even 1 or 2 nights without sleep, and we've all experienced this, I'm sure, you see that we're much more prone to fluctuations in our mood. We bounce across different states. We're much more irritable. We show much higher levels of anxiety. We've lost empathy. This is, I think, is so fascinating. We fail to pick up the social signals of our colleagues, our friends, our family. Increased levels of frustration, risk-taking, and impulsivity. The tired brain will think, "Oh, yeah, I'm sure I can get through that traffic light before it turns red," and it will try. Whereas the fully rested brain will say, "Don't be ridiculous. Of course you shouldn't. And why would you bother anyway?" That's a really interesting phenomenon. Negative salience, which is such an important area, and some lovely studies from Germany have showed that the tired brain remembers negative experiences but forgets the more positive ones. And so one's whole world view when you're tired is biased towards a remembrance of negative experiences. we're much more likely to slide into, because of these changes in our ability to use caffeine and other stimulants, and indeed alcohol and sedatives to try and reverse the effects of those stimulants. And so many people fall into the trap of driving the working day with endless cups of coffee, and of course, caffeine can last in the body 5 or even as much as 9 hours. So it comes to bedtime and think, "Oh my goodness, I've got to get some sleep. What am I going to do?" Well, I'll take a few drams of whiskey or whatever. And of course, that's a sedative. And like other sleeping tablets, that doesn't provide a biological mimic for sleep. It's a sedative. And in fact, it can disrupt some of the important things going on in the brain whilst we sleep. So those are some of the emotional impacts. If we think of cognitive responses, overall, our ability to process information is depressed after loss of sleep. Our ability to multitask. What we're good at as humans is being bombarded with information and then selecting out what's the most relevant and responding to that. And we're not good at that when we're tired. Our memory consolidation and our information processing. I mean, there's some really good stuff here about how we need sleep to process information. There's a wonderful study by Jan Born's group who he developed a really tough task that people had to perform, and he introduced it to one group in the morning, and they had to perform it that afternoon. So they became familiar with the task, had to perform it in the afternoon. Hard task, only about 20% of the group got the right answer. The second group, introduced to the task in the morning, they performed it the following afternoon, but they were deprived of sleep. Interestingly, about 20% of the group solved the problem. The third group, which is the interesting one, introduced to the task in the morning, became familiar with it, performed it the following afternoon, but allowed to sleep perfectly normally, 60 to 70% of the group solved the problem. Brilliant illustration of the importance of sleep for problem solving. And that goes along with our ability to, communicate and decision making and our whole creativity and productivity. And if we think about individuals, not just night shift workers, but other individuals in the workplace who are experiencing very little sleep, you see, of course, daytime sleepiness and microsleeps. There's a very interesting study on junior doctors showing that after the night shift, 57% of these individuals had either had a crash or a near miss driving home after the night shift. We see in night shift workers high rates of cardiovascular disease, altered stress responses. It seems that what a night shift worker has to do is a function when their entire biology is saying, you should be asleep. And the way to override that, and we may be the only species that can really do that, is to activate the stress axis. So we're throwing out lots of glucose into the circulation. Heart rate is going up. We're sort of forcing our bodies to be active when they really want to sleep. The downside of those altered stress responses is lowered immunity. The one thing we know about high levels of cortisol is it suppresses the immune system, and you see higher rates of infection. In night shift workers, you also see higher rates of cancer. So some very important studies on night shift nurses has shown higher rates of colorectal cancer and breast cancer. And the data are so strong that the World Health Organization has now designated night shift work as a probable carcinogen because of those correlates. You get metabolic abnormalities because, again, massively altered stress responses, type 2 diabetes, and also, and this is an area where we have worked, is levels of depression and psychosis can become worse after sleep disruption. And finally, if that wasn't enough, that poor sleep during the middle years, and I mean, highly disrupted sleep during the middle years, has been associated with an increased risk of dementia as you age. And that could be as a result of a newly discovered toxin clearance system called the glymphatic system. This is something that can take out, toxins that can build up in the brain. One of which is beta amyloid, which of course is this misfolded protein which acts as like chewing gum in cells and gums them up and is associated with dementia. And it's been shown that when we sleep, the lymphatic system is particularly active and clears some of these toxins out of the body, which may be the correlation between why terrible sleep in middle years is a risk factor for dementia later on. I'd never say that poor sleep is going to cause dementia, but if you are vulnerable to the development of dementia, then getting poor sleep it could well be a risk factor.
I'm going to go back to a little bit of science again. Do you mind? How does our body clock regulate sleep? And I presume vice versa. How does sleep regulate the body clock?
Yeah. It's a really interesting area, and it's really important to stress that sleep is so much more than just the circadian system. Sleep involves a change in essentially every brain neurotransmitter from the wake to the sleep states. It's a huge switch, and it involves multiple neurotransmitters and multiple brain structures, and it's complicated. You'll be familiar with the non-REM, non-rapid eye movement, and rapid eye movement sleep. These different stages of sleep, which can take cycles of, depending on who you are, 70 minutes to 90 minutes. So there's complexity there, and so what determines the timing of going from these different states, REM versus non-REM, and also going from the wake state to the sleep state? And of course, the circadian system is critical. It timestamps everything. So now is the appropriate time to be awake. Now is the appropriate time to be asleep. But there's a second timer, which is perhaps the most intuitive, which is the longer you've been awake, the greater your need for sleep, the greater the sleep pressure. So what we see over the day is that from first thing in the morning, the sleep pressure is low and it builds and increases throughout the day. So in the late afternoon, sleep pressure is really high. We don't fall asleep because the circadian system is interacting with that sleep pressure, saying, no, no, this is daytime, you need to be awake. So the wakefulness drive from the clock increases and overrides that buildup of sleep pressure within the brain. Ironically, the circadian drive for wakefulness is at its highest just before we fall asleep. The clock then says, okay, now's a good time to go to sleep, and the sleep pressure kicks in and we go to sleep. Then, whilst we're asleep, the wakefulness drive from the clock is very, very low. And while we're asleep, that sleep pressure dissipates. So it declines the longer we've been asleep. So, under normal circumstances, morning comes around, the sleep pressure has completely dissipated. The clock is saying, okay, now it's time to wake up. So, the wakefulness drive kicks in, very, very low sleep pressure, and then we wake up. So you've got those two incredible timers causing the flip from wakefulness and sleep. What do we know about that sleep pressure? Well, very interestingly, one key element seems to be the buildup of adenosine within the brain. Now, ATP is the energy currency of all cells. And once it's been used up to release energy, one of the breakdown products is adenosine. And so adenosine is a very valuable marker of metabolism, as it were, being active. And so that seems to be an important marker, and there are adenosine receptors within the brain indicating how tired you are, which leads us to caffeine and coffee. The reason we feel more awake after a cup of coffee is because there's caffeine in the coffee. It blocks the adenosine receptors within the brain, which generally means that we can't detect how tired we are. That's why coffee makes us more alert. So you've got this incredible, beautiful alignment of biology to generate the sleep wake cycle. But you also asked about whether the sleep systems can interact with the circadian systems. And that's an area that myself and colleagues have been working on. And so one thing that we've found is that the longer you're awake, the higher the levels of adenosine build up within the brain. And that feeds back and makes the circadian clock less sensitive to light. So there's a very interesting pathway there, which we're just beginning to explore. But yeah, the two systems do talk to each other. They were originally conceived as, yep, this is the circadian drive, this is the homeostatic drive or the sleep pressure drive, and that's it. But they definitely talk to each other.
Based on what we know, And based on your experience in this field, I'd love to try and draw out some kind of basic principles to try and live in tandem with our body clocks. So we're going to focus primarily on doves to begin with, and we'll touch on maybe some other chronotypes. But for the kind of average majority, what are maybe some useful considerations to kind of live in tandem with our body clock?
Yeah, I think you make a really important point. And the first thing to say is that we're not all the same. There's huge variation in our chronotype, and in the duration of sleep that we need. And so the key point that I start with is, well, how do you know if you're not getting enough sleep? And it's not rocket science. If you feel as though you're not performing at your peak during the day, chances are you haven't had a good night of sleep. If you oversleep extensively on free days, let's say you're oversleeping at the weekend, that's a good sign you're not getting the sleep you need during the week. If you're dependent upon an alarm clock or somebody else to get you out of bed in the morning, if it takes you a long time to wake up, if you feel groggy, if you've got what's called this sleep inertia, if you feel sleepy, irritable, fatigued when you are awake, if you crave a nap during the day, or if your behavior, as we've touched on, is showing signs of being overly impulsive. If you crave caffeinated drinks and sugar-rich drinks. And also, it's worth listening to your family, friends, and colleagues. Do they comment on the fact that you are kind of a bit more irritable, you don't have the empathy, you're more disinhibited than you normally are? This is telling us that we're probably not getting the sleep that we need. And then the good news is, of course, there's lots of things that we can do about it. I think most people feel that sleep is what you get and we have no control. And there's lots of things that we can do to tailor our behavior to get the sleep that we need. And we can divide, that into, I guess, things that we can do during the day before we go to bed, the bedroom itself, and when we're in bed. And as we've touched on, if we start with during the day, for most individuals, 90% of individuals get that morning light. I call it a photon shower. And that's either going outside, or if it's winter, then sit in front of a light box. And the rule of thumb would be 10,000 lux or so for 30 minutes is a really robust way of setting the clock. Um, During the day, if you nap, be careful. If the fact that you might need a nap is telling you probably didn't get the sleep that you needed last night. But if you do nap, make sure it's not longer than 20 minutes or so. Because if it's longer, you can fall into a deeper sleep, and then recovery from that can actually make the whole nap a bit counterproductive. You just feel groggy. Where napping is really important to appreciate is in our youngsters. So, as we've said, the youngsters tend to be a delayed chronotype. So they'll go to bed late and they'll want to wake up late. But that can be exaggerated by social media. They're working until the early hours of the morning, doing whatever they do. So they get up, they struggle through the school day, and teachers tell me, literally, kids are falling asleep at the desk. They get home, and then they'll have a 2-hour sleep. And what that does is push back the sleep pressure, making it more difficult to get to sleep that night. So you've got the delayed chronotype of youngsters coupled with a reduction in sleep pressure, meaning you're not going to get that extended period of sleep at night. You wake up, or you don't wake up, you're woken up, you then struggle through the school day, and you can get into a really difficult cycle of longer and longer naps, and shorter nighttime sleep, and a failure to function optimally during the day. And as I say, that's a particular issue for our youngsters. Um, Exercise is very important. Do it during the day, but not too close to bedtime, because what that can do is raise up core body temperature, and a drop in core body temperature is important for getting us off to sleep. So yeah, exercise, ideally in the morning outside, because that does two things. It gives you the photon shower plus the exercise, but you can do it later in the day, that's fine, but make sure it's not too close to bedtime. um, your food intake, this is an interesting area. So we're geared up to do different things across the day. And so if you give individuals a constant infusion of glucose, you'll see that that glucose is absorbed and used up during the first half of the day, but it hangs around for much longer if you give it during the second half of the day. And as you're approaching bedtime and reduced activity, it won't be burnt up. So it'll then be laid down as fat or other forms of storage in the liver. And that can lead to a whole bunch of problems in terms of metabolic abnormalities and obesity, which will impact upon sleep. So try and minimize your calorie intake later in the day, if possible. Um, I think the really important issue is that you stop drinking coffee by 2, 3 o'clock in the afternoon, certainly no later, because it will delay sleep onset for the mechanisms we discussed earlier. And I think an absolutely key point is that most people don't have a sleep issue. It's an anxiety or a stress issue. So, what you must do is step back at the end of the day and do relaxation techniques. You may want to go to the gym to burn it off. What I do is go for a swim. And it's all about managing that stress, because that's the real enemy of sleep. As I say, most people don't have a sleep problem. It's managing anxiety and stress. If we think about before bed, we've talked about, light levels, and it does make sense to reduce light levels um, to about 30 minutes before bedtime. But it doesn't have to be complete darkness, but it just needs to be a bit lower. That not only is impacting on the clock, but also the brighter the light, the higher the levels of alertness. And if you're really alert, that's going to delay sleep onset. So, dimish levels of light, especially that 30 minutes before you want to get to sleep. Electronic devices, stop using them 30 minutes again before bedtime. So put your smartphone, put your computer, take all of that out, and don't be distracted by it. Um, I think it's very important that before bedtime you avoid prescription drugs or sedatives or sleeping tablets. Now, clearly, you need to talk about this with your general practitioner. And a short course of sleeping tablets can be useful, to correct a sleep wobble. And you may be going through some trauma, for example. But long-term use is counterproductive. It's in fact disrupting some of the key things going on in the brain whilst we sleep, our ability to store information, process information, and all the other things that we've talked about. Again, not only prescription drugs, but the use of alcohol as a sedative, or many people will use antihistamines that can cross the blood-brain barrier as a way of getting to sleep. These are, again, highly not recommended. Um, so before bed, I think it's tricky because for many individuals, many families and couples, and the only time you really get a chance to talk to each other in an overpacked day is before you go to bed. So you're lying in bed, and you start to talk about the things that are important. And certainly in my family, we don't talk about family finances or anything like that before bedtime. These are stressful, and that's the thing you really must get rid of. So schedule a time to deal with those difficult issues. Don't do it before you go to bed. So if we think about the bedroom, for most people, it shouldn't be too warm. So 17 to 18. Again, it's that thing about core body temperature. If the bedroom's too warm, you won't show that drop in core body temperature, and it's going to be more difficult to get off to sleep. Um, Again, it's tricky if you're living in an environment where there's lots of noise, traffic noise, noise from the neighbors, then use white noise or some other device that can just block that out. Keep it dark. Again, it's useful because you don't want that light coming through the window, for example. So use blackout curtains, which will sort of increase levels of alertness. Again, I emphasize this in the bedroom itself. You really don't want televisions or computers or tablets or smartphones. I know that, from the time of COVID, so many of us used our bedrooms as offices, and it's very, very counterproductive. The bedroom should be this cocoon. This is the place where you go and sleep. And that's so important. One thing that many people do is they make clock watch, and we'll talk about waking up in the middle of the night. But trying to get to sleep, or if you wake up in the middle of the night and you've got an illuminated dial on your clock, you think, "Oh my God, I've only got 2 hours before the alarm goes off." That induces stress, so you cover it up. It's not actually how long you've got before the alarm goes off, but when it goes off that's the important information. Don't unnecessarily stress yourself. I would argue very strongly that you don't take sleep apps too seriously. They're a bit of fun, but at the moment, they're not sophisticated enough to give you a really reliable metric of your sleep. So you'll see some apps saying, "Oh, you had a good night's sleep," or "You had a bad night's sleep." It's largely nonsense. So don't rely on them. I mean, the marketing model is people get anxious about their sleep. They buy a sleep app to find out how good or bad their sleep is. They realize it has no resemblance to what's actually occurring, and they shove it in the drawer after 6 months. And finally, in bed, keep to a routine. We've touched on this, that routine of light exposure, but also get up and go to bed at the same time each day, including weekends and free days. It's important to get that stability. Um, I think we Brits are kind of a bit mean about spending money on a bed, a mattress, pillows, duvet. I'm not sure why we're like that, but I've noticed it in many of us, and there's a sliver of it in me. It's worth bearing in mind that 30% of our time will be spent in bed. So why not indulge in a beautiful duvet and a mattress and wonderful pillows that relax you? Keep bedside lights low, of course, because that will increase alertness. You may want to define the bed and the bedroom using relaxing oils. Now, the data behind this isn't particularly strong, but there are some studies which have said that if you use lavender, for example, and you've defined the sleeping space with a particular smell, then that can be useful in helping you get into the mindset of sleep. And what I know some people do is if they travel a lot, they may take their partner's perfume or aftershave and drop a few, drops on the pillow because it'll again remind them of home and being with the safety of their partner. Earplugs can be very useful if a partner snores. And this is really important because snoring can represent a number of things. First of all, it can just be irritating. If your partner's had too much to drink, it'll relax the musculature of the nose and the throat and it'll make them snore more. But you've got to look out for obstructive sleep apnea, which is where the musculature of the throat essentially closes, so you can't breathe. The brain realizes it's been deprived of oxygen and it'll wake its owner up and with great big sort of snoring and spluttering. And that's accompanied by huge surges in blood pressure, which can damage small vasculature. So if you've got obstructive sleep apnea, you've got to get it looked at. It's incredible how resistant people are. Partners will say, "I think you've got a sleeping, snoring issue. I want you to go and get it looked at." They say, "No, no, 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 I'm fine." But there are apps, again, you can download which can monitor for obstructive sleep apnea. And I've said this, previously, and I stick by it, that if your partner disturbs you, whether it's snoring, whether they're too hot, whatever it is, it's not a reflection upon your relationship that you sleep in an alternative space. And I think many people do that. But I know I've spoken to some elderly couples and they said, "Oh, no, 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 it's the beginning of the end of our relationship." It isn't. It's the beginning of a new relationship where you're rested, you'll be more empathetic, you'll have a better sense of humor, and you'll enjoy each other's company far more. And then the final point, and I know I'm sorry I've gone on for a long time, but I just want to emphasize how many things there are you can do, is that if you wake in the middle of the night, it is not necessarily the end of sleep. It looks like the default human sleep pattern, particularly as we get older, is to experience biphasic or polyphasic sleep. And what I mean by that is you go to bed, you go to sleep, you then wake up. You may wake up for 10 minutes, it may be half an hour or longer, and then you'll go back to sleep again. But the key point is that if you wake, you stay relaxed. You might want to leave the bed and do something relaxing elsewhere. What many people do is that they plug into Radio 4 Extra and they'll listen to a play, or a very popular program is In Our Time with Melvin Bragg, that gets people back off to sleep very easily. I mean, whatever works for you. but don't worry about waking up in the middle of the night. You'll almost certainly get back to sleep again if you remain calm. And above all, it's defining what works for you and then sticking to that routine. And don't be pushed around by so-called sleep experts. Work out what works for you.
Now, my wife, she might want me saying this, and I might not include it in the final interview. My wife seems to really not like light in the morning. So she comes down and she puts her arm around the door and switches the lights off. And then she comes into the kitchen and she just wants peace and quiet. Now, could that be that she is a late chronotype? So it leads me on to a couple of questions. How do you know what chronotype you are? Presumably,
Yeah.
you've mentioned there are certain ages where you're more likely to be a certain chronotype. But how do you know? And then leading on to probably an even more difficult question, what should we do about it? Should we try to entrain ourselves to be more within a modernly acceptable, and I don't mean that in a bad way. I hope people understand what I mean, like a 9 to 5 society? Or should society be more aware and adapt to suit other people's chronotypes? There's a lot in that, I'm sorry.
Yeah. Well, first of all, if we start with your wife, it sounds like she is a late chronotype. And so, should we change our sleep preferences? So there's sleep wake timing and there's sleep wake duration. That can vary, sleep wake duration can vary enormously. The healthy range from the National Sleep Foundation is between 6 hours and 10 and a half, 11. And that's a healthy range. The one thing I would say is that we've got to distinguish sleep needs versus fatigue. Now, sleepiness is cured by sleeping. Fatigue is not. The classic, of course, is long COVID, where people are sleeping much, much longer, but they're still feeling down, they're feeling tired, and they're lacking in energy. And what fatigue is an indicator of is some underlying health issues. So do be sensitive to the fact that if you do adapt and you have longer sleep, but you're still feeling tired, that could be fatigue. And you need to discuss that with your general practitioner. Okay, so we've got all these variations in our sleep habits. Should we try and match them to our work schedules? Well, ideally, we should, if possible. So if you're a late person and you like to start work at 10 o'clock rather than at 8 o'clock, then I think that's valuable. I don't think it's. I mean, if you want the optimum performance from your workforce, allow them to get the sleep that they really need, and to adapt their sleep habits to their sleep needs. And if it means a slightly later start, I think that's perfectly reasonable. Um, I think where it becomes really important is in night shift work. And so what you tend to find are lots of sort of different sorts of patterns, revolving forward, revolving back, whatever. But what we've got to be sure about is that a late person isn't put on an early shift. There are things that an employer can do to try and match the biology of the individual to their activity wake patterns. While we're talking about employers and night shift work, I think there is a real issue of a duty of care here. So, for example, knowing that chronic sleep loss, and particularly in night shift workers, is associated with high rates of diabetes 2, obesity, coronary heart disease, we should be having higher frequency health checks of those individuals to catch these conditions before they become chronic, uh, and including stress, of course. Knowing high rates of obesity, type 2 diabetes, what kind of food do we provide for our night shift workers? Well, it couldn't be worse. It's vending machines full of high fat, high sugar, and it's canteens full of, really high fat, high sugar meals. And I think it's about time we addressed that and provided our night shift work with protein rich, easy to digest foods, and move away from some of the really bad stuff that will enhance, our development of things like type 2 diabetes. I think education is critically important. So it's worth bearing in mind that we not only need to let individuals know about some of the consequences of working night shift or getting very little sleep on their health so they can make informed decisions, but we need to let their partners know what's going on. It's worth bearing in mind that in some sectors, the divorce rate is some sixfold higher in night shift workers compared to day shift workers doing the same job. Partners need to know that this person hasn't turned into a monster, but these behavioral changes that you're seeing are an inevitable consequence of driving biology outside of its normal range over a relatively long period of time. So I think there's a duty of care there, and we've got to pay more attention to that. Oh, and one final point, of course, we go back to our junior doctors, who 57% reporting either a crash or a near miss on the drive home. They should be either given or advised to use apps which can detect if the car is moving laterally or if the head is nodding. Many, of course, new cars have this, but many don't. And so, wake up devices, if you're clearly falling asleep at the wheel, will have an immense impact upon saving the lives of both the drivers and other people who may be on the road.
Someone who's done a lot of night shifts over the years, I kind of have my own strong opinions on it. But I'm curious if it isn't a luxury and it's simply part of your job, and there are industries that just have to provide a 24-hour service. What at least are some things that we definitely should be doing from an individual level to minimize the impact, and maybe the employers, what should they be thinking about?
Well, there will be a lot of differences in impact between individuals. But one area where we have good data is that if individuals have had a sustained good diet, low fat, low sugar, and they regularly exercise, even as long-term night shift workers, they can reduce the chance of developing things like type 2 diabetes and other metabolic issues. So we need to take our health particularly seriously as a night shift worker. And I've advocated that what employers should do is give gym membership passes to night shift workers to encourage them, because it's expensive. Many gyms are expensive, but this would be a great way of improving the longer term health of those individuals. Another area where we don't have data is limiting night shifts. So what you might want to do is say, okay, you can do it for 4 years or 5 years, and then you rotate off for 5 years, and then you maybe rotate back on. We don't have the data to show that that would unwind some of the damage. Intuitively, I think it probably would, but it would be great to get those long-term studies. Now, the problem there, of course, is money. So most people don't really want to do night shift work, but of course, you get paid time and a half or more, and it's often the only way that, let's say, a nurse can combine a job with children. And so the kids can be got off to bed, partner's there, looks after them overnight. The nurse is on night shift. They get back in the morning to get the kids back off to school. And that's sort of an economic, drive. That's how you can combine a career with also children and bringing sufficient money into the household. So it's a huge tension. Um, but I think we need to educate and we need to explain the consequences of long-term night shift work to individuals so that they can make an informed decision about whether they should, um, and for how long they should do it. I think the problem is that because we can do night shift, we do, and we do it all the time. And there are many cases where we don't necessarily need a workforce active across the 24-hour day. Our frontline staff, yes, of course. But there are other sectors where I think maybe we should just back off and start to think about whether do we really need this in view of the consequences to these individuals? But again, it's a financial issue. Going back to our doing night shift for 4 or 5 years, then coming off it. Well, would we pay them the same rate? And those are the sorts of questions that need to be answered, I think.
You mentioned already, I'm just going to follow on from something you mentioned a little bit earlier, and that was about matching your chronotype to the
Yeah.
job. Do you think there's an element of, in those industries which maybe don't have a choice, there's maybe a benefit in matching people? Not that you want people to be consistently on night shifts, but at least trying to match people's chronotype as much as you can to different shift patterns.
I feel that it would be very sensible to match one's chronotype to the demands of the night shift. So if you are a late type, night shift work is going to be easier than an owl, and vice versa. So I think, and it's not that difficult to work out one's chronotype. I mean, in the back of Lifetime, there's a questionnaire which one can use, and there are questionnaires, good questionnaires online that you could use as well. And so, yeah, I think there is an advantage in matching one's chronotype to the various demands. There are another few tricks, though. So once you finish the night shift, you need to come back and sleep as soon as you possibly can. So the sleep pressure will be high, but the wakefulness drive from the clock won't necessarily have kicked in. And so you can get a longer sort of block of sleep if you sleep immediately after you've come back from the night shift. The problem with that, of course, is that many people will take a cup of coffee to make sure they don't fall asleep on the drive home. And we need to sort that issue out as well. But one trick is, as I say, to sleep as soon as you get back. Don't wait for later in the day, because then the circadian drive for wakefulness will have kicked in, and it'll be much more difficult to try and get to sleep. And the great problem with night shift work is that the sleep pressure, homeostatic drive for sleep, and the circadian drive for wakefulness are completely misaligned. And that's why it's so difficult to try and sleep during the day. Another trick that night shift workers use, and I think it will depend upon the individual again, is that they sleep fairly close to when they start their night shift, sort of an hour or maybe more. Because what that will do is it'll push back the sleep pressure, which means they will be more alert and able to function during the first half, certainly, of the night shift compared to not sleeping. But that's very variable. It depends upon the individual. One of the great problems there is you can fall into very deep sleep, and then you feel sluggish and groggy, and it doesn't help. But for some people, that is a tactic that they use.
I recently read your book and I thought there was some very interesting other aspects of health that can be impacted by or improved or benefited by timing with
Yeah.
your circadian rhythm. Would you mind just giving us some of those examples?
Yeah, I think one of the really interesting areas is chronopharmacology. Because pathologies, whether it be rheumatoid versus osteoarthritis, whether it be migraines, whether it would be stroke, can all happen at specific times across the 24-hour day, it would be most important to take your medications when they are optimally effective. Two areas I think are incredibly important, and one is in anti-cancer treatments. So in childhood leukemia, in ovarian cancer, and in radiotherapy, there are nice studies showing that treatment at a particular time of day can have a big impact upon long-term survival. So I'm thinking of the ovarian cancer study, which showed over a 5-year period, timing of the drug at one time of the day versus another time of the day. We had 40% survival in one group, and the other group, it was 10% survival. So same drug, same concentration, but different time, a big effect upon long-term survival. There's some evidence in stroke. So, for example, most strokes, or 50% of strokes, occur between 6 a.m. and 12 noon. So when should you take your antihypertensive, for example? And the data from at least one group shows that if you take it the night before, this will reduce your chances of death from stroke. And the logic is these antihypertensives, they have a long half-life. They hang around for a long time in the body. You take them before you go to bed. They're still at sufficiently high concentrations in the morning when blood pressure starts to increase. and you're vulnerable for stroke. So you take it then, so you can blunt that sharp rise in blood pressure. If you take it later, the time you've woken up, the time you've remembered to take the antihypertensive, and the time it's kicked in, you're often past that danger window. So there are lots of examples. I mean, aspirin, for example, should be taken. Aspirin, which is very good at reducing blood viscosity, it actually stops the platelets sticking together, and that has been shown to be much more effective if you take it before you go to bed rather than first thing in the morning. That's because the platelets are made at night, and it wipes their stickiness out. And so that effectively means, yes, the platelets are there, but they're not sticky. So that's a great way of coinciding your drug with its optimum efficacy.
Any key developments in the field? What's on the horizon from sleep and circadian rhythm
Yeah.
research?
I think this is a very exciting time, and many researchers like myself who've done fundamental and basic science for much of their career are now looking at the possibilities of translating this science for human health. So my own team, working with colleagues, is that because we understand how light interacts with the molecular clockwork, we now have drugs that can fool the clock that it's seen light. Now, why is that important? Well, as we discussed, if you have no eyes, you're time blind, and you drift through the rest of your life getting up and going to bed at different times. And this particular drug, we hope, will be introduced to the profoundly blind to regulate their sleep wake cycle. I mean, I'm very excited because if I can end my career by giving back a sense of time to the time blind, I think that will be just wonderful. But it also has a broader application. We see very massively disrupted sleep wake cycles in severe mental illness, in dementia, in neurodevelopmental conditions. And this could also be very powerful to stabilize the circadian clock and the sleep wake cycle in those individuals. So I think we're living in a really exciting time.
Are there any other myths you would like to debunk?
Well, I'd just like to emphasize, you know, that the sergeant majors of sleep have been screaming, if you don't get 8 hours, you're going to die. And this is just deeply unhelpful. As we discussed, natural sleep can range from 6 hours to over 10. And it's all about finding out what your individual sleep needs are and stop listening to these screaming experts.
Professor Foster Russell, thank you very much. Just before you go, would you like to just leave our listeners with just a final kind of take home message?
Oh, oh yes, thank you. Yes, I think we should stop thinking of sleep as this monster that needs to be grappled with, subdued and bludgeoned into submission. It should be treated much more like a sort of a bit of a naughty puppy, that we need to give it a bit of a cuddle, embrace it, and we'll get so much more out of it. That would be my final analogy about how we should treat our sleep.
Russell, thank you so very, very much for your time. I've really, really enjoyed and learned so much from this, and thank you for helping
Well,
us
thank
to.
you. I've enjoyed it too.
Thank you so much. Take
All
care.
right, then. Take care. Speak soon. Bye bye.